Neodymium. Neodymium is a silvery metal that belongs to the rare earth family. It's used to make the powerful magnets inside electric cars, wind turbines, and even your earphones. Those tiny but super strong magnets that make your earbuds sound great, that's neodymium at work. It's mined mainly in Inner Mongolia, China. The big issue, though, is that producing these magnets generates a lot of hazardous waste, and the demand keeps rising fast. Samarium. Samarium is a silvery white metal that can resist high temperatures and demagnetization. It's used in samarium cobalt magnets found in jet engines, missile systems, and high-end headphones. It's also used in nuclear reactors to absorb neutrons. Before neodymium magnets were invented, samarium magnets were the strongest available, and they're still used where high heat would damage others. Like many rare earths, its mining leaves behind toxic waste. Yttrium. Yttrium isn't technically a lanthanide, but behaves so similarly that it's grouped with them. It's used in LEDs, lasers, ceramics, and superconductors. It's also the reason old CRT TVs glowed red. Yttrium conducts heat well and helps materials handle high temperatures. It's fairly abundant, but tricky to separate from other rare earths. Cerium. Cerium is the most abundant rare earth element. It's shiny but easily oxidizes, and even catches fire when finely powdered. Cerium plays a huge role in cleaning our air. It's used in catalytic converters to reduce car emissions, and it's also in glass polishing powders and self-cleaning ovens. Jewelers love it for polishing gemstones. While it's useful, the extraction process can harm the environment if not done carefully. Lanthanum. Lanthanum is a soft, silvery metal that reacts quickly when exposed to air. It might not look like much, but lanthanum helps refine gasoline, powers hybrid car batteries, and even sharpens the image in high-quality camera lenses. Interestingly, it used to be used in old movie projectors to make those bright, white lights on the big screen. The downside? Mining it can produce toxic waste if not properly managed. Dysprosium. Dysprosium is another heat-resistant metal, essential for electric vehicles and wind turbines. It keeps magnets strong even at very high temperatures. Without dysprosium, electric car motors could lose power as they heat up. Again, China produces more than 90% of it, and demand is quickly outpacing supply. That makes it one of the most critical rare earths for the future of renewable energy. Europium. Europium is soft and silvery, but incredibly fluorescent. It glows under ultraviolet light. It's what made the red color in old TV screens and fluorescent lamps, and today it's still used in LEDs and computer monitors. Europium gives the vivid red and blue hues in your display. The catch? It's difficult to recycle, so most of it ends up as electronic waste. Gadolinium. Gadolinium has a unique superpower. It can absorb an enormous number of neutrons and becomes magnetic at very low temperatures. That's why it's used in MRI machines as a contrast agent and in nuclear reactors for safety. It's also added to alloys to improve their properties. While it's useful, trace amounts can stay in the human body after medical use, which scientists are still studying. Praseodymium. Praseodymium is a yellowish metal with strong magnetic and optical properties. It strengthens metals for jet engines and gives glass a green tint. The name itself means green twin in Greek, which perfectly fits its color effects. However, like many rare earths, it takes a lot of energy to separate it from other minerals. Terbium. Terbium is a soft gray metal that glows bright green under UV light. It's one of the reasons our phone and TV screens can display that perfect green color. It also helps magnets stay stable at high temperatures, which makes it valuable for electric motors. Terbium is rare and expensive Because it's so limited, recycling terbium is becoming increasingly important. Scandium. Scandium is a light silvery metal often used to strengthen aluminum. You'll find it in aerospace components, bicycle frames, and even sports equipment like baseball bats. It's incredibly rare, though. Global production each year could fit inside a suitcase. Because it's hard to find and expensive to extract, scandium can cost several $1,000s per kilogram. Major producers include China, Russia, and Ukraine. Erbium. Erbium has a gentle pinkish color and plays a key role in modern communication. It absorbs and emits infrared light, which makes it perfect for fiber optic cables, the technology that carries internet data across oceans. It's also used in lasers and skin treatment devices. Without erbium, long-distance internet would be much slower. Holmium. Holmium is a metal with the highest magnetic strength of any element. It's used in lasers, nuclear reactors, and experimental quantum computers. A tiny piece of holmium can flip its magnetic state with very little energy, which could make it useful for next-generation data storage. It's hard to separate from other heavy, rare earths, which makes it expensive to produce. Lutetium. Lutetium is the heaviest and most expensive of all rare earths. It's dense, stable, and used in PET scan detectors and oil refining catalysts. It's also used in research instruments that detect radiation. Because it's so rare, a small amount can cost thousands of dollars per gram. Supplies are extremely limited and mostly come from China and Australia. Ytterbium. Ytterbium is soft and malleable and used in atomic research, precision instruments, and even quantum computing. It helps improve the performance of certain lasers and atomic clocks. It's also being explored for use in next-generation technology because of its stable atomic behavior. Thulium. Thulium is one of the rarest rare earths. It's silvery and used in portable X-ray machines and laser equipment. It's extremely valuable, but produced in very small quantities. Even though it's rare, thulium's light emission properties make it important in high-tech medical tools. Since it's so scarce, it's often lost during mining and processing. Promethium. Promethium is a bit different. It's actually radioactive and very rare in nature. Scientists usually produce it in nuclear reactors. It glows faintly in the dark and is used in nuclear batteries and some types of luminous paint. The name comes from Prometheus, the Greek titan who stole fire from the gods. Fitting, since this element literally emits light. Because it's radioactive, handling and disposal must be done carefully. So that's all 17 rare earth elements. They might not be rare in quantity, but they're rare because of how difficult they are to mine and process. They're essential to everything from clean energy to modern electronics. But their extraction comes with environmental challenges and geopolitical tension, especially since one country controls most of the supply. These elements are the hidden foundation of our modern world, powering our phones, cars, wind turbines, and even medical technology. The challenge for the future is finding cleaner, safer, and more sustainable ways to source and recycle them. If you learned something new today, make sure to like, subscribe, and share this video. And tell me in the comments, which rare earth surprised you the most? Thanks for watching, and I'll see you in the next one.